Hello, good afternoon, everyone. My name is Rakha and today I will explain about CLO3 and CLO4 assignment part 2 with advanced calculus subject. So, as for the first question, okay, so we need to find, so this is the given path of plane. The storm electric instruct a pilot flying at an altitude of 4 miles to make a 90-degree horizontal turn while climbing to a 4.2 mile depend of the plane. The model by this equation right here, RT 10 cos 10 pt 10 sine 10 pt 4 plus 0.2 t, which t is greater or equal than 0 or smaller than or equal than 1 over 20. So first we need to find the speed of the plane during the maneuver. So here we need to find the vt, which will be the dr over dt. So d over dt, which consists of 10 cos 10 pt is equal to minus 100 p sine 10 pt, then d over dt 10 sine times 10 sine 10 vt is 100 p cos 10 pi t. Then we have d over dt, which will be 4 plus 0.2 t equals to 0.2. As now vt is 1 minus 100 p sine 10 pt, and then 100 p cos 10 pt 0.2. So we need to find the extreme, the no, not the extreme, like the norm of this, and then to find it we just 100 p square sine square 10 p plus t, and then plus cos square 10 p t, and then plus 0.2 square will result in 314.16. So p here is 3.3, like 3.14, so it will approximately be 314.16. And then b we need to find tangential and normal components of acceleration at and an, which one is 0 and y. Okay, so how to find it? We need to find at, which is dv over dt. So again, d over dt minus 100 p sine 10 pi t equal to minus 100 pi times 10 pi cos 10 pi t equals to minus 1000 pi square cos 10 pi t, and then that will result in d over dt 100 pi cos 10 pi t is equal to minus 1000 pi square sine 10 pi t equals to d over dt, which is will be substituted and it will get 0.2, which is it will be 0. So at is minus 1000 pi square cos pi cos 10 pi t and minus 1000 pi square sine 10 pi t 0. Then we need to find the at with a big T, and then d over dt is the magnitude of vt. So d over dt of magnitude vt is 0, right? So at t is equal at 0, so a n will be a time at 1 square minus a square t, then at will become 0. At is 0, right? So a n will be oh, no, my bad. So a n is the root of the magnitude of a t square minus a square t. So a t will be is 0, right? So a n is equal to magnitude of at, which is right here, or the norm, you could say. So minus 1000 pi square cos 10 pi t square plus minus 1000 pi square sine 10 pi t square plus 0. So we need to plug out the 1000 pi square here, and then we will get, after this we will get 1000 pi square, which pi square is approximately 9.8696, and then an will be 1000 times 9.8696 will be 9,869, no, and 0.6 miles per hour square. No, I think we don't need the square here. And so conclusively, speed of the plane is approximately 314.60 miles per hour. Tangential component is at equals to 0 because the speed is constant, and normal component an approximately 9869.6 miles per hour. And for the second question, so we need to find if a car can safely travels at 30 miles per hour at the point 1 and 1 over 3, how fast can it safely travel at the point 3 over 2 and 9 over 8. So for a curve y equals to fx, the k here is y, the second derivative, over 1 plus y square power of 3 over 2, where y is 1 over 3 x3. We will get 2x for the second derivative. Calculate curvature at both points. So at, which is 1 and 1t, is, we know that y here is x2, so because it's 1, we'll plug in 1, 1. Second derivative, it 2x, will plug in 1, here will be 2. K1 is the positive of 2 over 1 plus 1 square power of 3 over 2, so it will be 2 over 1 plus 1 power of 3 over 2, and then will be 2, 2, 3 power 3 over 2, 2 over 2 root 2, 1 over root 2, and then because root cannot be in the bottom, so we just use root 2 over 2 with add 3 over 2 and 9 over 8. We just plug in the same again, we result in 9 over 4, and plug in the same for this right here, and then it will be 2 times 3 over 2, it will be 3. K2 is 3 over 1 plus 9 over 4 power of 3 over 2, and 3 over 13 over 4 power of 3 over 2, 3 over 13, 3 over 13 power of 3 over 2 minus over 8 equals to 3 times 8 over 13, 3 power of 3 over 2, because this 8 will go here, and then will result in 24 over 13 power of 3 over 2. So we use the inverse square root relationship here, and then this v2 over v1 is root k1 over k2, so v2 is v1 times root of k1 over k2 is will be v1 is 30 times 1 over root of 2 over 24 over 13 power of 3 over 2, so 1 over root 2 over 24 over 13 over 3 power of 3 over 2, and then it will become this, and we will take the root again of this, and will result in 13 power of 3 over 4 over root of 24 root of 2. So it will become 2 k over root 2, it will be 24 root 2, it will be 24 times 1.4142, it will be approximately 33.941, and then we will take the root of 13 over 0.941, approximately 5.828, and will be 13 power of 3 and 4, it will be 13 power of 0.75, approximately 13 power of 0.75, approximately 7.368. So V2 will be 30 times 7.368 over 5,000 no 5.828, so approximately 30 times 1.264, approximately 37.92 miles per hour. So the car can safely travel at approximately 37.92 miles per hour. So for the B, interpret the geometric significance of curvature in terms of road safety. So the curvature measures how sharply a curve bends at a given point. So high curvature will mean sharper turn and higher risk at higher speeds. And then low curvature will be a gentle turn and then safer at higher speeds. Since the maximum safe speed is inversely proportional to the square root of curvature, it will be on sharper turns on the higher surface. Cars must travel slower to maintain safety, and then on gentle curves uh, or lower curvatures, cars can travel faster without increasing risk. For the third question, we need to compute the gradient factor gradient t and interpret its direction in the context of heat flow. First, we need to find the partial derivatives. For the tx will be dou t over dou x equals to 400 times exponent power of negative x squared plus y over z times negative x will be negative 400x times exponent power of negative x squared plus y over 2 here. Okay, so ty will be dou t over dou y will be 400 times exponent power of x squared plus y over 2 times 1 over 2, because it's respect to y, equals to negative 200 exponent power of negative x squared plus y over 2. I think this is negative, sorry. So gradient t is tx, will be tx, and ty will be tx will be this one here, and then ty will be this one here. So heat natural flows in the direction opposite to gradient t from high to low temperature, and gradient t indicates the direction where temperature rises most rapidly, but heat flows in the opposite direction. So for the B, we need to find a unit direction vector from 3 and 5 in which the temperature remains constant. So the direction of no temperature change is orthogonal to the gradient t. So we need to find which is the orthogonal, which will be 0. So tx 3 and 5 will be negative 400 times 3 times exponent power of negative 9 plus 5 over 2 will be negative 1200 exponent power of negative 7. The 3 will be x from here, and then the 5 will be y for here. Okay, same for the ty, it will result in negative 200 times exponent power of negative 7. So the gradient factor t, which respect to 3 and 5, will be negative 1200 and exponent times exponent power of negative 7 and negative 200 exponent time power of negative 7. So it will be exponent negative 7 times negative 1200 and negative 200, and then we need to find the perpendicular vector will be gradient t times v times v will be 0. So negative 1200 vx times and minus 200 vy will be 0. So it will 6 vx plus vy will be 0 also. So vy here it's so because it will be 0, so negative 6 vx. So we need to find the unit vector. We already find the vx and the vy. So the norm of v is 1 square here 1, and plus negative 6 square here is 6. So we need to find it, the root 1 plus 36 is square root the root of 7. So the 37 I mean. So the unit vector is 1 over 37 over root of 37. It will be times 1 and minus 6 for the I and j here. So 1 over root 37I and then minus 6 over root 37J. So for the fourth question, we need to find the values of x1, x2 that maximizes the profit. So A, we need to put the cost functions into profit function. For the P, it will be the P x1 x2, it will be 15 x1 plus x2 minus 0.02 x for the first x squared plus 4 for the first x plus 500 and then negative 0.05 x for the second x squared plus 4x second and then plus 275. From where does this belong? Because C1 here is this and then C2 here is this. So minus 0.02x for the no, we can calculate all this and it will result in 0.02x. The first one is x squared plus 11x the first one and then negative and then minus 0.05x squared for the second x and then plus 11x for the second x and then it will negative 775 from here negative minus here. So we need to take the partial derivative and set it to 0. So dou p over dou x for the first one is negative 0.04x first one plus 11 is equal to 0. So x1 is 11 over 0.04. It will be 225. Then dou p over dou x square dou x the second one, it will be minus negative 0.1 x square x the second one plus 11 is equal to 0. So x2 it will be 11 over 0.1. It will be 110. So x1 is 275 and x2 is 110. To maximize total profit, interpret the result in terms of how many units each location should produce. So to maximize total profit, the company should produce 275 units at location 1 and 110 units at location 2. So this production allocation balances the profit per unit against the increasing marginal cost at each location. So I think that's it for my presentation for the assignment 3 and assignment CLO3 and 4. I hope this is clear enough for to understand, and yeah, I think that's it for me. Good afternoon everyone. Yeah, thank you and goodbye.